Hello, welcome to Bedroom Builds at the rsytup series, episode 5, YouTube API, coming from the previous episode where we spoke about thumbnail creation. So in this episode, we'll talk about how we can access the YouTube API and do a minimal listing of the top 5 videos. So the points we will be going through are, first of all, how do we authorize YouTube API access? This will be done using an existing asynchronous client for the Google APIs in general. Once we went over that, we show how we can make this easy to use for the end user. And finally, we will list the top 5 videos on YouTube as of today. The crates used are the async Google APIs command crate. So we will generate our API wrapper with the async Google APIs crate. And once we have that, we will use this one because this holds all the common things that these APIs share. Then the env logger is used by this Google API crate to do a debug logging of, for example, your HTTP request against the API. Hyper is the low-level HTTP client that they chose to use to implement all of this. Tokyo was chosen as the executor for async code, and the web browser crate is fairly cool. It is a small crate that allows you to open the default browser on many operating systems. Now let's look at the theory as how this goes with talking to the YouTube API. For this, we will scroll down to a nice drawing. So if you are familiar at all with OAuth 2 or the OpenID Connect protocol, then you will know all of this already. So first of all, we have a user. This user uses our rsytup software. This user also has a web browser, hopefully. These are the tasks that run on the computer of the person itself. And then we will have the authentication server of Google that then gives us access to the YouTube API. So how does this work? So the user will want to list the top 5 YouTube videos, tells that to our rsytup client. The rsytup client now is configured with a client secret, hands this over to the auth server. This one sends us a redirect URL back. Since rsytup is a command line client and not a web application, it will now use this URL to open it in the web browser of the user. To open this URL can also be done manually, of course. So our command line client could print out the URL, tell the user to copy and paste it into the browser, but that is a step that can be automated for the user. So once the user is in the web browser, it will be asked to authenticate in the user interface of Google in this case. The user can now authorize the application to access the YouTube API in his name. So this user data is now sent over to the authentication server. This one verifies it. Once this has happened, this gives an authorization code to rsytup. This one line is actually more complicated than that because it actually would go with a redirect to the web browser that then would redirect onto a small web server that runs on rsytup that then takes the auth code. But this drawing is already really big, so I took that out. And rsytup ends up with the auth code. That's the point of this drawing. Once it has the auth code, it can present it to the auth server. Once the auth server accepted that one, we get an access token. This whole process continues. Further down, so we were returned an access token, and with this access token, we can now call the API that is running on the YouTube API backend server. And of course, when this token is an accepted token, we actually get an answer back that is useful. One more arrow is missing because now rsytup is presenting the results to the user. So all of this process is very, very complicated and elaborate. And it's very good that there is actually already a crate out there that handles all of this. we kind of have to understand how this works to know why we would have to set up and configure a client secret, and what this actually means that, for example, the access token is cached. This whole process to end up with an access token is part of the OAuth 2 or OpenID Connect specification. This is a very vast topic and fairly interesting though. If you want to read up on this, I encourage you to do so, because there are many small details that should not be overlooked when implementing this yourself. But again, luckily we don't have to. It has been done for us. Let's quickly hop over into the code and check out our first changes. So as we already established, this will be an asynchronous client. So the biggest change that happened since last time is that we are using the Tokyo main executor attribute to make our now async main function run the executor and therefore be asynchronous. And further down in the code, we can see that within the list command for the YouTube top 5, we are now actually building a service, handing it over to the video list function, and this will then do the listing of the top 5 videos. Great. We have now our YouTube module that does stuff. Let's look into the YouTube module. If we hop over to the other code, go to the first line. So the first one is our OAuth flow. This will be the one that does the opening of the browser for the user, so they don't have to copy paste a URL. And the other one is this YouTube v3 types module that I have imported with a shortened name called YT. So how do we get to this YouTube v3 types module? Because that is actually fairly big, and this is a wrapper around all the API calls that exists on the REST API of YouTube. This is a generated file, and this can be done fairly easily. If we look at the documentation of the README of the async Google APIs crate, we can see that they provide Google Drive, cloud storage, and YouTube APIs, and you have to run a Python script that generates the Rust code for you. So this I have already done. I've ran this pipenv run generate APIs, but here I didn't use storage. I used YouTube version 3. So this code is not written by me. This was generated by that amazing crate. And with this, we can now continue in our YouTube code. We again use also this common crate that holds the shared parts of the generated code and of course stuff that you will need to actually use this async Google API. First thing we will need is an HTTPS client, and we are going to use the hyper crate and using the Rust TLS library instead of the OpenSSL to have a Rust native TLS client. So all this function does is it builds us a hyper client in the most minimal configuration possible. Then again, a helper function that is run internally inside this YouTube API is now already an async one. It will create a service. The YouTube API has different service types, so there's a difference between uploading a video and, for example, changing the metadata afterwards. And for that, we want to have a helper function that only builds us a base service, and then we would actually connect to the sub service within the API. Let's scroll a bit down to see the whole function. So here we can see now the whole service basics. So first we instantiate our HTTPS client with the helper that we just spoke about. And now here's in the comment already that we have to put the client secret into the working directory. So what's the client secret? This client secret.json you can download from your Google developers account. And let's check out how this will look. So I have a client secret example. And in here, you can see that we have a JSON file that has a client ID. This will be some long string and then apps googleusercontent.com. And the client secret. Now this will be your secret for your client that you have created. In the case of rsytup, this is a client that has been written for you, but since you are individually using this for your YouTube account, you will have to register your own client secret. And then here are just the informations of where you can authenticate and get a token. All right, back to our YouTube code. So after we have read the client secret, we can now instantiate an OAuth 2 installed Flow Authenticator. This is one of the many flows that OpenID Connect or OAuth 2 offers. This one makes the most sense for the rsytup application because it behaves like an installed application. In order to actually get something back from this authentication flow, we have to hand over our client secret and we have to tell how we want to receive the responses. In our case, it is HTTP redirect. Once we have successfully achieved to get some excess tokens, we can store them in a token cache. Luckily, the creators of this amazing client library have allowed us to do that. So we call this builder pattern method persists token to disk. And this will be handled for us. This is amazing because with that, once you have a token, there is no more browser redirect happening. We directly use the token and directly access the YouTube API. Then we can custom delegate what happens within our flow. This is what we will be using to open the browser for the users. So I call my OAuth flows module installed flow browser delegate. And with this, the browser will be opened for the user and it doesn't have to copy paste the URL. And then we clone the HTTPS client into the hyperclient builder pattern method. And here we build finally our authenticator. This is an asynchronous function, so we have to await it. And if this fails, we will actually panic out of there. After that, we return a tuple. And this is this weird definition up here. So this one will be a hyperclient that is an HTTPS connector. And the other one is the OAuth 2 authenticator. Great, now we have the service basics. Now we actually want to have access to the video service. This one will now load the service basics. And here we can now define the scopes that we want to use. So we want to be able to upload and we want to enforce the use of SSL. Once we have told which scopes we want to use with our connection, we can now open the video service using our HTTPS client that was returned from the service basics and with the authentication that was also returned from our service basics. And once we have that, we can set the scopes that we want to use and return this. And now this video service, if you remember, will be handed over to the YouTube video list function. So let's check this one out. That's the last thing that happens in this chain. So the video list now has the video service as our argument. We hand this over as a mutable reference. Now we have to define the YouTube parameters. Now this is coming out of this generated code that we have been provided. And there we now have to provide the general YouTube API parameters, which are defaulting to this, and we choose to want to see every field possible. Then we will have to create the videos list parameters. And for that, we pass the general parameters that we just created. Then we want to see the YouTube's video ID, content details, and the snippet details. And the thing that we want to see are the most popular videos. All we have to do now is use our client, call the list method with our parameters. Then we wait for it or panic out if this doesn't work. And then we can see in the response our items, and we can loop over the videos that we found in the response if it was successful. And here we can now print line. First, the video's ID, then content details. This map is actually on an option type because this is returned from JSON, and the JSON, this content details can be none, and therefore we only want to continue in the tree if we actually have a value behind that. So map will pass now the content details. Inside the content details, we can check if there's a duration. If there's no duration, we want to show that it's not available. So here we do the unwrap or else. Therefore, this will either be successfully returning the duration value, or it will return this not available string. Same we do with snippet. So if snippet works out, we map the snippet's title. If we have no title, which can happen, then we want to show NA not available again. Now for our browser opening thing, you will notice that this is called src, where our main is also inside, right? Is the youtube.rs. So inside this YouTube module, we can now add more submodules. So one of them is this version 3 API that was generated, and another one is our custom flow. And this can be done by a subdirectory. If we now open source YouTube OAuth flow, we can see that this is now a submodule inside our YouTube module. This big documentation string comes from this being an example for the Google API crate that I've written how you would create a custom flow like that. So I copy pasted my own code into my project. So the first thing we are doing, we will have to import the traits that we are going to implement for our custom flow. So these two we have to pull in. Since as of today in Rust, we cannot use async functions when we implement a trait. We have to return a future for a normal function for this then to be able to be used by an asynchronous engine. And we have to pin stuff because this is necessary for asynchronous code for memory management reasons. So this asynchronous browser user URL function is a helper that will show the URL to the user as if it was just run by the normal flow, but also tries to open it in the browser. So here we can check for that. If this successfully was done, we can let the user know, but also we use the default one. And this now actually also prints out the URL. So if for some reason the web browser was closed or didn't really open, the user still has a chance to copy and paste anyways. Then we create our custom flow. This is an empty struct because there's nothing special that will be stored inside. We just need a type. And once we have that type, we can implement the trait for it. Down here, we are implementing the installed flow delegate trait for our struct. And what we do here is we only define the present user URL method. We can do that because there are already default implementations for all the methods of this trait. But since we want to customize how this present user URL is working, we are doing the custom opening of the browser and presenting it to the user on the terminal. Since trait does not have the possibility to directly use an async method, we have to work around this by using a pinned box that holds a future. And this is exactly what this does. We are using a box and pin the reference to our async function that we have defined up here. And our async function is nothing else but a future that will provide an output. This is the result type. You can see here that we have a string return type and a string error type. That's exactly what the associated type output of our future holds, is the result with the strings. The next guarantee we have to give, this has to be send. And with this, we can actually make this work in an asynchronous context. And one more syntax sugar that needs explaining is this tick A. That's a lifetime annotation that we need to make sure that the reference to self, the reference to our string slice holding the URL, has the same lifetime as does the future returned. That's why it is added here as an additional bound. Long story short, due to the limitation of async functions not yet working within traits, it simply wraps up our asynchronous function into a pinned box, and this way we can still use traits for the implementation and stay within an asynchronous execution. So once we have run through all of this sugar, it's not many lines actually, we can now open the browser for the user. Cool. That concludes how we actually implemented what we want to do in code. Let's look at how this works in practice. This means I have to close the editor, which I will do now. And here we can run the listing of the top 5. So if we now do cargo run, we're using 2 dashes to pass arguments to our rsytup. We want to list, and we want to list the YT top 5. So let's see what happens. So here you can see that this actually works. So we have this YouTube's video ID that has a duration of 10 minutes and 50 seconds apparently. And the title is Don't Open the Wrong Box. I don't know. There seems to be some music. Most wanted videos. Interesting. Oh, the John Oliver is in the top. Who knew? And some football stuff. Now let's go over what happens if we do not have a token cache. So we can see that we have a token cache. I can remove that one. And we can actually look at the token cache. Let's do that quickly. Here you can see that the access tokens will be some long strings handed to you, and there's a refresh token. So if your access token runs out of expiry time, so you can see here that there is an expiry time added to that. With the refresh token, you can get again an access token. This is again part of the whole OAuth flow process. And that is automatically done for you by this amazing client library. Let's exit out of that and run our list of YT top 5 again. So now it will open up the default browser and ask for our permission. Okay, so my default browser on this operating system is Safari. And sorry, this will be bright and white because, well, it's Google, so it will be white. And this will be shown in German because that's my native language. I was too lazy to switch my Google account back to English. But anyways, this is what will be opened. You can see here that when we zoom in, we get to choose our bedroom builds. And once we have opened the bedroom builds, it will now tell us that this application was not verified by Google. Well, we didn't upload it to their app store, so they cannot verify it. So we have to go and open it anyways, then you will have to give the access to the things that we requested. So the one will be YouTube upload, right? And the other one will be comments and modification of subtitles and stuff like that. So if we want to give those two, then we can click the yes, we agree that thing. And here it actually shows already you may close this window. So this is on our local host, the small web server that runs within rsytup that handles the token. Now that we run and jumped through those hoops, we can go back to our cargo run. And again, we have listed the top 5 of this instance, and they actually stayed the same. And here you can see what happens in the case that you have a token cache. So there's no further output. It directly lists the top 5. But here it opens the browser window and tells you that it was successfully done. However, this also shows you the full URL that you can copy paste to your browser if this operation for some reason failed. And after that is done and we have successfully obtained the access token, the API access works out and we get our top 5 videos. So this concludes how we can get access to the YouTube API or any other Google API for that matter. Thanks for watching. Coming up next on the rsytup series will be actually uploading a video, uploading a thumbnail, and adding the just uploaded video to a playlist.